what we're going to demonstrate is the Coriolis Acceleration. What we've got here is a turntable. Up here we've got a pendulum attached to the rotational table, and that moves backwards and forwards as such, so it's quite independent of the motion of the turntable. At the top of the turntable we've got this Wi-Fi camera. This transmits a signal to the computer. The computer then projects the image up on the screen here via a video projector. Alright, let us start with and we can either have the camera rotating with the turntable frame of reference, or if we hold the camera still like this, holding the handle, the camera is in the frame of the reference of Earth. So we'll start off swinging the pendulum. It's just going basically in a straight lines backwards and forth, and when we rotate the turntable you can still see the pendulum is basically going backwards and forth with the camera in the frame of reference with the Earth. So the camera is fixed with the frame of the reference of the Earth, so the pendulum appears to be going straight backwards and forwards. Alright, let us start again. This time we'll have the camera in the frame of reference of the turntable, and we'll see what happens. As you can see, the motion of the billiard ball is quite erratic. Appears to be going in a curved manner of motion and not straight, but as soon as we hold the camera stationary to the frame of the Earth, it appears to be going in a straight line. As soon as we let go of the camera, it is rotating with the frame of reference of the turntable, therefore it appears to be going in a spiral-like curved manner. This is a so-called fictitious force, but it has relevance to the Earth, especially with the climatic conditions of the Earth. So if we've got wind travelling from, say, the mid-latitudes toward the equator, the wind gets deflected to the left, and therefore we get mainly southeasterly trade winds in the subtropic areas and the tropics, whereas if we've got wind travelling from the mid-latitudes towards the pole, they get deflected to the left again, but it's the winds travel to the south pole, therefore it turns out to be a westerly, so we get all these westerly winds in the temperate to subpolar regions of the Earth. So that's an example of Coriolis force. Also, when we empty a bath of water, we take out the plug and it spirals in a whirlpool. The direction of the spiral depends on which hemisphere of the Earth you're in, north or south. North it'll rotate in one direction, but in the south it'll rotate in the opposite direction, counterclockwise or anti-clockwise. That's due to Coriolis, so it does have effect on the Earth.